This is the Introduction to Computing and Programming in Python and Multimedia Approach, the 4th edition, Chapter 6, Modifying Pixels by Position. So to start, the chapter learning goals are to mirror pictures horizontally or vertically, to compose pictures into one another and create collages, to rotate pictures, to scale pictures smaller or larger, to use blending to combine images, to be able to add text and shapes to existing pictures, and to use blurring to smooth degradation. The computer science goals are to use nested loops for addressing elements of a matrix, to loop through only part of an array, to develop some debugging strategies, specifically to use print statements to explore executing code, to be able to choose between using vector and bitmapped image formats, to be able to choose when one should write a program for a task versus using existing application software. So there are four conditional statements in this program for turning the uh, red flowers in the arc into uh, I don't know why it just cuts off. I'm assuming into black flowers, right? Because that's what the picture looks like in the bottom. So one of these generated this image. Which one was it? We're going to use the distance the distance from C to red, which is C is the color. So the distance from the color to red is less than 200. If the red is greater than 100 and the blue and green is less than 100, if the red is greater than 150 and blue and green is less than 200, or if the red is greater than the blue and the green. So we can probably say um, it's not going to be the distance because that's less than 200. So that would affect a lot. That would affect a lot more than just that. I would assume that the pink would probably be affected by that one as well. If the red is greater than 100 or 150 and the blue and the green is less than 200, I would probably say it's number three. So continuing, pixels are in a matrix. Matrices have two dimensions, a height and a width. We can reference any element in the matrix with x, y, or horizontal vertical. We refer to these coordinates as index numbers or indices. One is an index, multiple, more than one are part of are part of indices. We sometimes want to know where a pixel is, and get pixels doesn't let us know that. So arrays versus matrices. Figure 1 is an example of an array. So there's four objects. The length of the array is 4. We always start counting at 0. Um, if I said give me the value in index 1, you would return 12. Give me the value in index 3, you would return 10. Uh, figure 4.2 is an example of a matrix, which is a double array, right? So we can see that it's not just going across, but it's going down as well. So they're rows and columns. So if I said give me the object at 1 1, you would return 7. If I said 2 3, you would say 10. So pixels in a matrix. So you can see that the horse picture on the right side is made up of uh, 0 to 479 going across. So there's 479 columns, and then there's 639 rows. So based on that, or actually, sorry, because it's 0 to 479, that means there's 480 and then 640. So we can see that we get height and we get the width and we can print those values here. What if we wanted to print the pixel at, this is the horse picture, so it's H00, we could actually get the pixel and it's saying that this right in the very corner is 627849, and we can similarly work with that. But for example, if we wanted to get 480 and 640, right, we're only going from 0 to 479 and 0 to 639. So 480 and 640 is not a valid spot. So we get this error, an appropriate argument. Um, the 480 is greater than the width of 479. So indices from the function range. Range returns a sequence between its first two inputs, possibly using a third input as the increment. So if I said print range 1 to 4, I would get an array of 1, 2, and 3. If I said print range from -1 to 3, -1, 0, 1, 2, range from 1, 10, 2. In this case, it uses an increment, so it's it skips 2, right? So it's 1, 3, 5, 7, 9. If I said print the range of 3, we assume that it starts at 0. Like it says, notice here, if you leave out the start value, it's assumed to be 0. So if I said print range, it's going to be 0, or print range of 3, it's going to be 0, 1, 2. Side note, the thing in the brackets is a sequence. So A of 1, 2, and 3, if I say print A, it's 1, 2, and 3. A equals A plus 4, we're going to throw an exception, right? Because that's not a valid thing. But if I said A equals A plus, and then in other brackets 4, right? That's adding two arrays together, which we can do. So then that combines the arrays, and I get the array of 1, 2, 3, and 4. If I wanted to print a certain value, I could say, give me the value at index of 0, like A of index of 0, and I would return 1. So we can use range to generate index numbers. We'll do this by working the range from 0 to the height minus 1 and 0 to the width minus 1. Using the range function will make it easier to start from 0 and stop before the end value. But we'll need more than one loop. Each for loop can only change one variable. We'll need two for indexing a matrix. Working the pixels by number. To use range, we'll have to use nested loops. One to walk the width, and the other to walk the height. But be sure to watch your blocks and indent carefully. Right, so if you look down here, it's saying for x in the range, then we're saying for y in the range, and then do something on x, y, and then as it goes, so it's gonna go through the x row, the x row, right? Once it goes through, it's gonna start in the very x row. It's gonna go through every single y. Go through all the y's. Then it's gonna keep incrementing these, incrementing these, incrementing these. When these are all incremented for all the y's in that range, then it's gonna increment the x. Then it's gonna increment the y again and continue, continue, and so on and so forth. So what's going on here? The first time through the first loop, x is the name for 0. We'll be processing the first column of the pixels in the picture. Now the inner loop. Now we set y to 0. We're going to process each of the pixels in the first column. With x equals 0 and y equals 0, we get the leftmost pixel and increase the red by 10%. Then we set it to 1, the next value in the sequence, range, get height picture. X is still 0, now y is 1, so we increase the red for pixel 0, 1. Do the same thing for 2, and then we continue on, and then we end up increasing the x as well. So lightening a picture with nested loops. So we can see that we go through again, and we get the color at the pixel at the x and y location, we make it lighter, and then we set the color. So what function did A? So we can see that it's kind of looks like maybe a little less than a third is possibly normal color. Can't really tell what the picture is. Then there's lighter, and then it's lighter. So based on that, because it looks like it's a third, we can tell that number 1 is probably the one that did that because there's something that says for y in range, right, 0 to h over 3. We can tell it looks like a third, right? So we can assume that that's actually what it is. And then we do a half, so then we can see what this weird overlap is probably because they're a little bit overlapping, right? This is half and half, this is half and half here. So because it's a third and a half, we can see this weird section of overlap right here is probably caused by those overlapping as well. So we're going to say 1 is the answer. So reducing red eye with nested loops. So to remove red eye, we have a picture x, y, x, y for the rectangle around the eye, and then the end color that we want to. And this is far faster than the previous version that we did before. So we check the distance, and if it's less than 65, it's going to set the color. So timing. So say we want to actually time how fast it takes to execute our function. We can say from time import clock, so we can import the clock. We can say start equals clock, and it actually will start the time. And then at the very end, we can print out clock minus start, and it'll be the difference between the start time and the end time. So to get the end time itself, it's just clock minus start. So based on that, we can see that our removing of the, what is this actually? This is yellow box 1, yellow box 2. I believe that this is for. I was thinking it was for the removal of the eye color thing, but I don't believe it is. So this is just going through and modifying the color to be yellow of whatever picture you pass in. So based on that, we can see that for pixel and get pixels, if we look at the time for that, we can see that it's actually 1.3. I'm not sure what unit of units this is. I believe I'm assuming it's seconds. And if we do a double for loop, like here, it's 0.003. So it's significantly faster to use two for loops within each other. So what can you do if you know where the pixels are? One answer is mirroring. Imagine a mirror horizontally across the picture vertically. What would you see? How do you generate that digitally? We simply copy the colors of pixels from one place to the other. So we work it out with matrices. Mirror point is the halfway across get width of picture divided by 2. So we can see left pixel, right pixel. So if the left pixel is xy, the right pixel is at width minus x minus 1, y. So what you can do if you know where the pixels are is mirroring. Oops, sorry, we actually looked at that. So the recipe for mirroring. So to mirror vertically, we have the function below. We get the mirror point, which is the width divided by 2. We get the width for source. If I actually were to write this function over again, we'd actually put this width line above here because it makes more sense to see how we're calling get width here twice. Get width source, get width source. Makes more sense to get the width initially and then just make mirror point equals width divided by 2. Just some optimization. It's always good to, once you go through your functions again, to optimize them to be the best they can be. So that's just something that can be done at a later point. So we go through the y's and we go through the x's. The x only goes to the mirror point, as we can see right there, right? Left pixel equals source xy. Right pixel equals source width minus x minus 1 and then y. The color equals get the color, and then we set the color. So what can we do a horizontal mirror? So to do the horizontal mirror, we do the height divided by 2, right? We go through the pixels, we update them, similar to what we just did for the vertical mirror. And we can get something similar to that. So what if we wanted to copy the bottom to the top? Very simple. We just swap the order of pixels in the bottom lines. Right, so we're doing X and Y here, and bottom pixel here, and top pixel. So the color is top, bottom pixel, top pixel. And we can see it looks like that, mirroring bottom to top instead of top to bottom. So doing something useful with mirroring. Mirroring can be used to create interesting effects, but can also be used to create realistic effects. Consider this image from a trip to Athens, Greece. Can we repair the temple by mirroring the complete part onto the broken part? So you can use media tools to find the mirror point and the range that we want to copy. Writing functions for specific files generally. The function to mirror the temple needs to work for one and only one file, but we still don't want to write out the whole path. Set media path allows us to pick a directory where a media will be stored. Get media path will generate the entire path for us to use as file name in the media directory. This only works when we're accessing files in the media directory and where the files have set the path first. Some utility functions. If you know the name of the file, searching for it with pick a file feels tedious. You can set and get a media folder path for remembering a place where your media will be coming from or going to. Set media path lets you pick a file in your media folder. Uh, get media path base file name lets you generate a complete file name out of only the last part. So set media path, we can say new media path is that source, and then we can say get media path barbara.jpg, shows that, and we can also make a picture, get media path, and barb. So program to mirror the temple. We can see based on the inputs that we had from the media tools, and we can see that it returns this. It's clear it did the mirroring, but that doesn't create a 100% realistic image. Check the shadows, for example. Which direction is the sun coming from? Right, so because we mirrored this image completely from this side onto this side, we can see that these shadows on here aren't too accurate. Understand the temple fix. What is the very first transfer of pixels from and to? Which XY pixel from, which XY pixel to? What is second? How many pixels get copied? So adding print statements to see what's happening. We can add print statements to as our function iterates through multiple times through the X and Y, the rows and columns of the picture, we can kind of see what's going on. So it helps us understand maybe what point of the program it is. If you're getting an exception, perhaps we can even see why we're getting the exception by printing some information like that. So we can see that by adding our print statement, it'll print out copying color 1327, right, to 553827, and then so on and so forth. We could see it incrementing and decrementing, so we know that it's actually copying from this pixel location to this pixel location. So counting pixels. One thing that we can do is we can add print statements and counts, so we know how many pixels we're actually going through. We know as a class that we can use there's a different way to actually get the number of pixels that are there, right? But this gives us a method that we can count as we go through our for loop. So we set count equal to 0 here, and then we have count equals count plus 1 inside the y range. And if we print that out at the end, right, where we print out we copied, comma, count, right? So it's going to print we copied, then the count, then the pixels. And it says we copied 18,410 pixels. So where did that come from? How many rows? Y goes from 27 to 97. That's 70 rows. How many columns? 13 to 276. That's 263 columns. 70 times 263 equals 18,410. So what function did this? So it kind of looks like that this guy right here is kind of mirrored, right? But it's also, the red is also kind of odd as well. It looks like the red maybe was increased. And then there's a halfway point uh, that looks like the width divided by 2. So we can see that they're both width divided by 2, so that's not going to help us figure it out. We're going through the left pixel equals the get pixel xy. Let's try to find what the difference is first. So get red equals the right pixel, set red left pixel, set red right pixel. So I believe it's going to set the red of the left pixel. Let's see, left pixel equals the source, right pixel equals the other side. Set the red of the left, the right side. So it's actually kind of making almost a negative because it's only setting the red colors, right? But based on that, I believe that it is setting the red to the left pixel. I believe it's actually number 1 because it's setting the right pixel, the red value there. So I believe it's actually number 1 based on that. But go ahead and double check, make sure I'm correct. So the same function did not, or the same function below did the 2 pictures, but with 1 line difference. Which did which? So we're trying to figure out which function did which. So get pixels source x height minus y minus 1 mirror point. So we know there's going to be a mirror point, so it's probably not number 1, right? Plus y minus y. So we can probably assume that it's actually 2 and 3 because it's the mirrored point, right? Because we know there's a mirrored point here and there's a mirrored point here. Oops. Replacing colors in a range. We've done that before. It's going to go through here. We already talked about nested loops. So moving pixels across pictures. We've seen using index variables to track the pixel position we're working with in a picture. You can copy between pictures if we keep track of the source index variables, where we're getting the pixels from, the target index variables, where we're putting the pixels at. Not really copying the pixels, but replicating their color. What can you do that? What can you do then? What can you do when copying from one picture to another? You can do collages, copy several pictures into one. Cropping, you don't have to take the whole picture, or scaling, making the picture smaller or larger when copying it. So copying pixels. In general, what we do is keep track of a source X and source Y and a target X and target Y. We increment, add to them in pairs. Source X and target X get incremented together. Source Y and target Y get incremented together. The tricky part is setting the values inside the body of loops and incrementing at the bottom of loops. So copying Barb to a canvas. So we can see there's a picture of Barb here. and we get Barb's picture, we get a canvas picture, and now we actually do the copying. So we go through the source and we set the color of the pixel that's at the target. Or sorry, we get the color from the source, right? Barb picture, source X and source Y, and then we set the color of the to the canvas of target X, target Y. And then we return the Barb canvas and we show Barb and we show the canvas. So comments, we talked about how the hashtag symbol or the pound symbol ignores the line. So why do we want lines to be ignored? It shows notes on how to use the program, how it works, and how for other programmers to use it as well. Walking through the copying function, we can see the benefit of the comments here, right? It's very useful that we know we can understand more easily what this function is doing. So the actual copy, we get the color of the pixel at source X and Y. We set the copy, the color to the pixel in the target picture at target X and target Y. There's the copy loop, right? A double for loop. Ending the loop just before we end the source Y, we increment target Y. Now it's time for the next time through the loop. It's set correctly for the next value of source Y. Just before we end the source X loop, we increment the target X. Note that we carefully the indentation to figure out which goes to what loop. So make sure that you indent on your for loops because there's double for loops. A lot of things have to be shifted over. So just make sure your things line up, right? So we can see based on everything that's shifted over what is part of our for loop body and what's not. So what's this naming something as itself? So target x equals target x plus 1. This really isn't naming something as itself. Target x plus 1 is evaluated. It will result in the number after target x. Target x is then set to the value of target x. The result is target x gets incremented by 1. So we could take this as an example. We could say when it's your birthday, right? For example, I would say my birthday equals my age. So say I could say Professor Carpenter's age. I would say on my birthday, which is May 12th. So on May 12th, Professor Carpenter's age, which is my variable, equals Professor Carpenter's age plus 1. Right? So then every May 12th, then my age increments by 1 and becomes my next birthday or my next age for that year. So ending the copy function at the very end, we show the source and target, and we return the modified target as well. So it works either way. As long as we increment source x and source x and target x together, and source y and target y together, doesn't matter which is what in the for loop and which is incremented via the expression. So copying to the middle, we can see that we do that by the target x equals 100 and the target y equals 100. So we're actually starting in a different spot. So we're putting it into more of a spot that we want it to be and not in the corner, right? How this was prior, right? Because it starts at 0, 0, which is the origin. We're not copying there. We're going to copy to 100, 100 instead. So that's all that chapter 6 entails. Some things about matrices, some things about indices. So make sure you understand that kind of stuff. Picture placement is kind of important too. It'll help you with an assignment in the future as well. So make sure you're familiar with that. Nothing too crazy in this chapter, but as always, if you have any questions, feel free to let me know. Thanks, guys.